In this video, we will use the graph of a function to determine if the function is even, odd, or neither. Graphing is often one of the easiest ways to determine when a function is even, odd, or neither, especially if you have a graphing calculator available. You can type the function into the calculator, and after graphing it, look at the resulting graph, and it will generally provide an easy way to see if it's even or odd. When a function is even, the graph of that function will have symmetry over the y-axis, meaning it will reflect over y. If the graph is odd, it will have symmetry over the origin, meaning it has 180-degree rotational symmetry. Here's a rough sketch of the quadratic parent function y equals x squared. We want to know if this function is even, odd, or neither. If you'll notice, if we graph this function, we immediately notice that it reflects across the y-axis. We have point -1, and point 1, We have point -2, we have point 2. So those are reflections across the y. By definition, if a graph reflects across the y-axis or has symmetry across y, it is an even function. Therefore, the function y equals x squared is even. Here's an example of another function. This would actually be the transformation of a cube function. But we'll notice this time that if you look at a few of the points on here, for example, this one is pretty easy to see right here at 1, 2. You notice there is a corresponding point at -1, -2. Also up here at about, looks like about 1.5 here and about 4. And then also at -1.5 and -4 is the same point. This has rotational symmetry around the origin, meaning that it rotates 180 degrees, or it is symmetrical over the origin. It actually, if you just think of it as rotating this whole graph in this direction, you'll see that that rotation will take this portion of the graph and rotate it around and put that same part of the graph right down here. So this has rotational symmetry of 180 degrees, or it is symmetric over the origin. Therefore, this function is an odd function. But now let's take a look at this graph. I've used the basic shape, but notice this time I've shifted the whole graph upward by 1 and actually widened it out slightly. So this time, does this have symmetry across the y-axis? Well, no, so it's not even. But now we need to know, does it have symmetry over the origin? Does it have 180-degree rotational symmetry? And the answer is actually no. If we look at this point 1, 2, if there's a point at 1, 2, there would need to be a point at -1, -2 right here. And there isn't a point in there at that spot because of the way the graph is shifted up. If there was any rotation here, it would be around this point at 0, 1, not around the origin at 0, 0. Therefore, this graph is neither even nor odd, because it has neither rotational symmetry over the origin of 180 degrees, nor is it symmetric over the y-axis. Therefore, it is not even or odd. So in order to determine even and odd, we simply graph the function in a window that we can see if we have a graphing calculator, or if it's a small enough graph we can do it by hand, and just look at the symmetry to make that decision. Thanks for watching. I would appreciate it if you would leave a comment below to let me know if you like using graphs to find even and odd functions better than doing it algebraically. If you need to know how to do it algebraically or simply by looking at exponents, I have videos on my channel that will do that as well. If you found this video useful, I would appreciate it if you'd click that thumbs up button to like the video. And if you haven't done so already, hit that subscribe button to support the channel and help us make more videos. Also, you can visit my website at mymatheducation.com for more information and problem-solving steps, as well as my social media links. You'll find the link along with other links of interest in the description below. Thanks for your support, and thanks for watching.